Howdy folks, I'm Keith Bowen and this is Hard Rock University. What you're seeing here is a panoramic view from the side of the hill where California Prospect 1 is located, somewhere in the Mojave Desert. And this was an interesting prospect. We were contacted via the internet. A gentleman had a prospect. He'd taken about 7 samples. The worst one was about 0.8 ounces per ton according to the lab. The best one was about 8 ounces to the ton according to the lab. He reported 12 to 24 inch wide vein, and it was on BLM land, close to a major road and private property. So we're looking at a situation where theoretically we could mine it, haul it to private property, process it, dispose of the tailings back down in the played out workings and such, and be able to operate under the casual use rules from the BLM because there was essentially zero surface disturbance. So that was the setup, that's the information we had, and let me show you what the situation looks like in a diagram. Here's the setup. This is the hill, taller where I'm standing and smaller on the far side of the wall, sloping that way. We have a collar up here. The shaft goes down quite a ways. There's a cross tunnel here, all the way from one side of the hill to the other. The road gets right up to that tunnel. Shaft goes down. There's a stope to the side. We had to rappel down this rope and use a little platform to hoist up buckets of ore and our samples. There's a little stope here to the north, and there's a tunnel. Right here there's a big plug of timbers and stuff that have all just piled up in here. It's impossible to tell what's below there. We could see a tunnel going to this side, and on top of some collapsed rock there was a timber platform here at one time. We could go down in here into this tunnel. And so we took a number of samples here. We took vein samples here, here, and here. We took 2 altered wall rock samples here and here. We took a vein sample there, a vein sample there, and a vein sample there. Here is where it was reported 8 ounces to the ton. Now, this was too small an opening to get through. We did throw a few rocks and accidentally a light down here. And one of the rocks Jason threw made it down quite a ways. So it seemed pretty clear that there's substantial shaft past this, but how far we just couldn't tell. Anyhow, there is some significant shafting past this cross tunnel here. And we took those samples. We took a few other on surface, and that was basically it. Here's the level with the cross tunnel at the top of the usable shaft, and we've got a hoisting rope anchored above, and got our rappelling ropes anchored here. Okay, now here's the shaft itself, 50 to 60 feet down to that hoisting platform you can see. We've got the hoisting ropes in place, got a ladder in place, we have our rappelling ropes in place. So we're ready to rock and roll here. And this gives you an idea of what the situation is. And here's Jason actually rappelling down the shaft, getting to our work area. Now here I am taking video from the pile of collapsed rock and stuff at the beginning of that little tunnel to the north. I'm looking up here to the north, and you're seeing Jason at the end of the tunnel taking a sample with a demolition hammer, not the Hilti, it was a smaller one that the owner had. And then over here you can see the owner taking another sample up at the it's in the vein in the floor of the stope level but it's in the back of the tunnel level, you might call it. But anyhow, taking a sample there. And here we are, with Jason and the owner, taking a sample from the stope itself. This is where it comes down, and it was actually available to be sampled, where we could get to it with our minimal tooling. Now, here's some video of me in the shaft, halfway up. I'm 60 years old and kind of out of shape. I use certain muscles for climbing a rope using ascenders that you don't normally use. A lot of core body strength, which I don't do a lot of sit-ups. And so I was getting tired and I was taking a break here. And you can see how much is below me, the stope to the side of me, what's left on top. About another 20-25 feet is all. And we just decided it would be simpler if they lowered down the hoisting rope to give me a boost up, and that worked out very well. I could have probably made it without that, but hey, it was all rigged and ready to go. Why not? No sense overstressing yourself if you can avoid it. Okay, so that's what we did. We took a total of 7 samples in this area here, 5 from the vein, 2 from the wall rock. Brought them home, crushed them up. We got about 350 pounds here. Now, first thing I did was I just hand panned it to get an idea of what we're looking at. Here, here, and here looked fairly similar. I was guessing around an ounce to the ton. This one here looks significantly less. And these 2 vein samples here and the 2 wall rock samples in this area here looked like crap. I mean, really bad. So, that was significantly different than what we were expecting. I also took these 4 samples here, 1, 2, 3, 4, composited them and ran them over our separation table, and actually got some almost pure gold concentrates, and then 5 products. There's the coarse tailings, the fine tailings, the coarse slimes, the fine slimes, and the concentrates. Then, after getting all of these materials, I dried, weighed, and split down all those materials and sent it off with the rock samples, the rock splits, to the assay lab. And when it came back, this was about a 1/4 ounce to the ton, 1/4 ounce to the ton, 1/4 ounce to the ton, 0.05, and these were like 0.01 below detection limits, things like that. All the wall rock also had nothing significant in it. So we wound up with samples. These assays were substantially lower than what we were expecting. The question is, why? Well, my suspicion is primarily because size matters. Both in the size of the samples you take. If you take a small sample and you have to be either in an enriched area or a non-enriched area, you know, something that's extraordinarily poor, you're going to get a discrepancy. You know, review lesson 4, taking representative samples. Bigger is better if you can do it. And the other thing is, when it comes to assay labs, to a certain extent, bigger is better. Now, the state of Arizona actually did a test one time where they went to like over 100 different assay labs and sent them samples. Now, these were known samples. They knew what they were. And then they compared the results that these different assay labs gave them to the results that they knew they should have gotten. And interestingly enough, the more you pay for an assay, the less likely it is to be accurate. And the reason is simple. If you're paying more for an assay, it's probably a small lab that's making a lot of money on assaying. Let's suppose you're John Doe Miner. You find a little prospect and you go, wow, this looks really cool. And you take 3 samples and you send them off to the assay lab. And they come back crapola. What are you going to do? You're going to send them more samples? Probably not, because you got nothing to sample. On the other hand, if they come back 1 ounce to the ton, you're going to be taking a bunch more samples and sending it to that assay lab, And I have seen people who are actually charging over $400 an assay. So, I mean, if they can get you to give them an extra 8 assays, wow, that pays the bills for 2 months. So there is a financial incentive for assay labs, small ones especially, to give you good results when they're not real. On the other hand, a big assay lab, one that does thousands of samples for big companies, if they're not accurate, they're going to lose their business. Because those companies are going to go somewhere else. Because big companies will take like every 10th sample and send it off to another lab just to check for that kind of stuff. Okay? There's lots of reasons assay labs could make mistakes or screw with the results, so you really want to double check everything. And in this case, the owner sent some samples that we took to another lab and get back essentially the same results as we did on this stuff. It's running 1/4 of an ounce to the ton roughly in this area here. Now, found it interesting, there wasn't anything down here. They were just tunneling. I don't know, could have had a horseshoe going this way or kind of like this. They might have tunneled here with the assumption they're going to stope this out too. I really don't know because we couldn't get in there. But what I would sample next would be here and here, and then dig out enough of this, just dig out the rock, throw it in here, take the timbers, whatever it takes to get a safe passage through here. Stack your timbers in this stope. But right here, you're in a very dangerous situation. These timbers are just jammed together. When you're disturbing that pile, you have no idea when it's just going to go. So any work, while you're working this here, you're pulling timbers out and moving them, this should be done on a safety rope in a harness. Period. Because this entire thing can just collapse on you at any time. You need to be able to wind up hanging in midair safely. So you have to have a situation where you've got your ascenders with you, and you can switch to ascenders if you're not just hooked to them and using the ascenders as your belay point. But you need to be able to go to ascenders while hanging in midair if this stuff collapses out from underneath you. So that's the situation. What we found here, 1/4 of an ounce to the ton, between 12 and 24 inches wide. It's not bad. Don't know the extent. The haulage is a little bit difficult. Right now, I would, we need to find a lot more ore, preferably a lot higher grade ore too, to make it real interesting. That's why I'd like to check what's here. This stope is near vertical. It can be supported. You could even come in here and put a platform essentially and start backfilling the upper part of this stope while you mine down. That would be perfectly plausible if the grade is there. And there's a big block here between this stope and this stope. I don't know what the grade is there, but it might be pretty interesting. So I would do this. It also wouldn't hurt to actually sample this vein here from the shaft itself. It's kind of tricky, but it can be done. As you've seen in lesson 4, you can take samples while hanging on a rope. And then sample underneath here, and you would get the perimeter of this block here and determine whether that's interesting. You could also sample along the shaft on this part here. You could dig this plug out, throw the stuff here because this doesn't look very interesting. Get below it and possibly sample even deeper. See if you can see, is it getting richer or poorer as you go down or just staying about the same? It's important. If it's getting richer, hey, going down may be really useful. But this is also where the hand panning is really helpful. The hand panning gave essentially the same results as the lab, but just with less precision. Now that you've got it calibrated, you can see how much you get. We know what these look like, and they're 1/4 of an ounce to the ton. So as you're sampling here and hand panning, you can also get a good idea of what you've got. So that's where we recommended that the owner go from that point, and we'll see what happens. hopefully he'll find some really nice stuff there, and we can get a nice profitable joint venture going with it. Anyhow, that's the lesson for today. Happy prospecting. Keep it safe out there.